Today we're getting into more of the focus of a lot of this chapter, which is on rational expressions and rational equations. Our main focus today is on simplifying and multiplying. A rational expression is when you have two algebraic expressions separated by division such that the denominator cannot equal 0. Some examples are 1 over x, 2x minus 1 over x plus 1, x squared plus 1 over x squared minus 1. And we will be getting into showing how we define what the denominator cannot equal, so that way we can make sure that these are rational. So the first thing I want to do is I want to review how to simplify an expression. Remember, fractions are rational. So I look here and say, well, I know that 15 and 27 are both divisible by 3. So we're simply reducing fractions. 15 divided by 3 is 5, 27 divided by 3 is 9, giving us 5 ninths, or a simplified expression. Likewise, if we multiply two fractions, we can simplify ahead of time saying, well, I know 5 and 25 are both divisible by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. In the same way, 6 and 9 are both divisible by 3. 6 divided by 3 is 2, 9 divided by 3 is 3. And then we can finish it off by multiplying straight across. 2 times 1 is 2, 5 times 3 is 15. And by simplifying ahead of time, you have smaller numbers to work with. Then we look here at having 15x to the 4th, y to the 5th, 10xy squared. So I look here and I see that 15 and 10 are both divisible by 5, giving me 3 and 2. I have 4 x's here and I have 1 x here, which means I can cancel the 1x and I'm left with x to the 3rd. And then I have 5 y's and 2 y's, so I can cancel 2 of them, and that leaves me with y to the 3rd. And then I multiply it out. I have 3x cubed, y cubed on top, and on the bottom I have 2. In example D, I see that 10 and 6 are both divisible by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. I can cancel 4 of these x's, which leaves me with x to the 4th up top, giving me 5x to the 4th over 3. Now, then we get into having polynomials. And the first thing that we're going to do is to factor the numerator and denominator if possible. So I look here, x minus 5, that can't be factored, so I'm going to leave it x minus 5. I see x squared minus 25, that is a difference of squares. So I know that means that I have x plus 5 times x minus 5. And so then step 2 is going to be prior to canceling, we're going to use, and I'm asking you to do this because that's part of our process, we need to use that zero product property to find the x values for which the expression is undefined. And what that means is I need to look at this x minus 5, and if x minus 5 equals 0, that means x equals 5. But remember, this fraction bar right here is another symbol for division. And because it's a symbol for division, we cannot divide by 0, because if you put divide by 0 in a calculator, you will get an error. It is undefined. And so therefore, x cannot equal 5, so we need to make sure we identify. And we do this before we cancel, because even if you cancel it, it is still part of the original rational expression for which x cannot equal. Step 3 then is going to be to cancel any binomials that are in both the numerator and the denominator. Here I see that there's an x minus 5 in the top and bottom, which leaves me with this x plus 5, so that x plus 5 is my simplified expression. Moving on to example F. In example F, I see that in the top, I need to find two numbers that multiply to 5 and add to 6. So I know that that's x plus 5 times x plus 1. And then on the bottom, I need two numbers that multiply to -2 and add to -1. So I know that that's -2 and +1. So I look here, and according to the zero product property, if x plus 1 equals 0 or if x plus 2 equals 0, it makes the expression undefined. So therefore, if I do x plus 2 equal to 0, that means that x is -2, so x cannot equal -2. And if I do x minus 2, let me fix that. So therefore, x minus 2 equals 0, so therefore if x equals 2, x cannot equal. And if x plus 1 equals 0, then that means that x is -1, and x cannot equal -1. So those are for which it is undefined. Then if I look here, I see that there's an x plus 1 in both of them, and that means that my final expression is x plus 5 over x minus 2. Taking a look at example G, we have x squared minus 36 over 6 minus x. The first thing I want to do is rewrite the problem, x squared minus 36 and -x plus 6. So now when I factor, I see in the bottom that let's start with the top actually. I see that I have a difference of squares, so I have x plus 6, x minus 6. And now I look, and my bottom doesn't quite look like that, so I'm actually going to take this negative here, and I'm going to factor it out. And if I factor out a negative, that leaves me with positive x minus 6. And so then I can say, well, I know that if x minus 6 equals 0, that it'll be undefined. So x cannot equal 6. And then when I look here, I can cancel the x minus 6's, which would be x plus 6 over -1, which you can also, because you're dividing, you can stick it out front if you wanted to, but I would rather see you leave it like this.